Okay guys, so now we're going to keep talking about integration, right? I have another example here, which is 1 divided by x squared, right? And you want the integral of that with respect to dx. Let's do that. It's going to be x to the minus 1. Well, I'm just going to put a minus here, right? Because this is actually x to the minus 2, so plus 1, x to the minus 1, divided by this minus 1. So divided by minus 1, this is going to be equal to minus 1 divided by x plus c. Now, what the problem's informing us is that f of 1 equals 0. Okay, this f in here is not this one, because this is considered the derivative. So this thing here is actually f prime, okay? So this f here is this one, is the equation that we just integrated, the formula that we got by integrating. So f of 1 equals 0, so we have 0 equals, you replace the x for 1, so it's going to be minus 1, because minus 1 divided by 1, minus 1, plus c, so we know that c equals 1, okay? So actually the formula with the initial condition here is going to be minus 1 divided by x plus 1. Okay, now we're gonna have real world problem here to solve. Okay, look, a ball is thrown upward with an initial velocity of 64 feet per second. So the initial velocity, we're gonna say that x, because this is a physics problem, you gotta remember that s is the displacement, not the space, but the displacement vector, right? So the displacement vector, it has a magnitude and it has a direction. So it can be like this, it can be like this, it can be like this. Okay, this one is different from this one, different from this one, different from this one. Okay, so the displacement vector is going to be this one. ds dt is going to be the velocity vector. Okay, this is a vector, this is a vector, but maybe we're not gonna treat these as vectors. We're gonna treat them as equations. Okay, so s is actually a function of x, or of t in this case, of t, okay, with respect to time. And then you have ds of t dt, which is going to be v of t. V is also an equation with respect to time. And if you derive the equation as a function of t with respect to time, you have an acceleration function also with respect to time. All right, so keep these things in mind. So what does it say again? A ball is thrown upward with an initial velocity of 64 feet per second. So I'm going to say that s prime, because I'm not going to say ds dt, I'm just going to say s prime, okay? So s prime of 0, this is the initial condition, equals 64 feet per second. Okay, from an initial height of 80 feet, so we know that s of 0, okay, it's 80 feet. Fine. Find the position function given the height s as a function of the time t. Now, we also have to think that the acceleration here is going to be a constant, okay? Acceleration with respect to time equals minus 32 feet per second squared, which is the Earth, right? That's the gravity of the Earth. Acceleration is a function of t, but you don't have any t here. Yes, you do. Minus 32 equals minus 32 times t to the 0, right? So it's still a function of t, even though it's a constant. All right, so let us see this again. Find a position function given the height s as a function of the time t. So what it wants is this stuff right here. It's asking for s of t. What is this equation? Well, we got to find v of t. We have to integrate. So we're going to integrate a with respect to t, okay, I mean a of t with respect to t, so we can find v of t, okay, plus c. You gotta remember that. And then we're going to integrate this thing here so we can get s of t, right? I'm going to integrate then this equation, v of t, with respect to t, so that I can get s of t plus c. This c here is different from this c, okay? Because one is in one equation, the other one is in the other equation. So the integral of minus 32 dt is just going to be equals minus 32t plus c. All right, so this is the velocity thing. Now, what did it say? It said that at s0, the thing was 64. So you say that 64, okay, feet per second equals minus 32 times 0, it's 0, equals c. So 64 is c, all right? So we're going to replace this c here with a 64. So plus 64. All right. And now we're going to integrate this whole thing here to find s of t. So integrating, okay, minus 32t plus 64, okay, dt is going to give us minus 32t squared divided by 2. So that's minus 16t squared plus 64t plus c. All right, and it's saying that s of 0 equals 80. So this thing here at the 0 second, which is going to make this one and this one disappear, is equals 80. So we know that the c equals 80. All right, so I'm just going to get this thing out of here and put an 80 here. Okay, so that was letter A. Find the position function given the height s as a function of the time t. Okay, so we found it. This is number 1 in here. Okay. I'm just gonna do this in here. Okay, so this is done. Next, when does the ball hit the ground? Okay, so the ball hits the ground. This is gonna be the function s. What is s? Is the displacement vector or the value of the space. Now you gotta see that the ball is not going horizontally, okay? It's not going like this, it's not going like this. It's going straight up and down. So it goes up and then it goes down like so. Goes up straight and then stops, comes down straight, okay? So what is going to be saying again, when does the ball hit the ground? It wants to find out the time when it hits the ground. Okay? Okay, so given this function, the ball is going to hit the ground. What the heck is this? This function right here equals s of t. If I want when it hits the ground, I want s of t to be 0. Okay, so I'm just going to equate this thing to 0. So since I'm going to equate this to 0, I'm just going to change the I'm just going to change the sign, because you see that this is a quadratic equation and I like the a coefficient to be positive. Okay, and not only that, as a matter of fact, I'm going to divide this whole thing by minus 16. So minus 16 divided by minus 16 is 1. So you have t squared. Okay, minus, because I'm going to divide this by minus 16, equals 4. So minus 4t, okay, minus 80 divided by minus 16 equals minus 5. Right? Yeah. Equals 0 divided by minus 16, 0. Now, I think this is I'm going to try this. I'm not sure if this is going to work, but this seems to be a classic textbook example, okay? And when I have these textbook problems, sometimes the numbers are nice, okay? So we want two numbers that added to, well, yeah, that added together are going to be -4 and multiplied are going to be -5. So we know that this is going to be a positive, and I think this is going to be like this. So -5 times 1, -5. -5 plus 1, -4. There you go. Equals 0. Okay, now you have a t equals 5. Man, I can never make a 5. I think that I have some problem in my hand. And t equals -1. But you know, -1 is just going to go back to the past, because the initial time when the problem started, when the exercise started, was a 0. So -1 is going to go to the past. I don't want to go to the past. Okay, we threw something on the ground at, remember, it was at 80 feet. So let's just say that the ground was here. The ball was already here, being thrown with a velocity of 64 feet per second. Okay, and then it goes blah, 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 and it comes down and it's going to hit the ground, what? At time equals t, equals 5. Okay, so 5 seconds later, it's going to hit the ground. What does this -1 mean? It means, okay, that, well, it means that the ball was here 1 second ago. Okay, the ball was here 1 second ago, before 1 second in the past, before the exercise started, and then the ball was thrown up with a certain velocity, and it got to this point. Okay, because you see, guys, the initial velocity, because I know physics, okay, I know that the initial velocity was 64, right? That's what it says right here. So, knowing this, right? The initial velocity was this. Yeah, this is the thing here. Okay, doesn't matter. But anyway, the -1 says that 1 second before the problem started, the ball was here, and then 1 second later, when the problem started, the ball was here, and then the problem started, the exercise started, and the thing was thrown upward, okay, with a 64 feet per second, and it went up and it came down, and that's it. So this is letter A, because it's the equation of the space with respect to time, and this is letter B. That's when the ball hits the ground. Now we're going to have some exercises in integration just to fix things up. 2 divided by the square root of x dx. This equals 2, right? X to the times x to the minus half plus 1 x to the half. Okay, divided by half. So it's times 2. This thing here becomes a 4 plus c. Okay. Now you have the integral of t squared. This is going to be interesting. Plus 1 squared dt. All right. Of course, we can integrate this stuff like we're going to integrate this one. Okay. So I'm going to show you guys this stuff twice, in 2 different ways. Okay. So let's integrate the outer function, which is the square, divided by the derivative of the inner function. So this is going to be t squared plus 1 cubed divided by 3 divided by 2t, which is the derivative of the inner function. So this is going to be 6t. All right. Man, cubed. This thing is going to be a pain. Let's try. This equals t to the 6. Okay. Or yeah. T because this is a binomial expansion to cubed here, okay? So it's going to be, because this is already squared, when you do a cubed, you got t to the 6 plus 3, all right? And I know it's going to be t to the 4th plus times 1 plus 3t squared times 1, t squared, because it's this thing now elevated to 1 and this elevated to 2, so it's just going to be that, plus 1 cubed, and divide this by 6t. And you have a plus c too. I just want to see something here. Oh no, it's squared. Hold on. Yeah, this is already the integration. Okay. So because what I did, you gotta see here too. Okay. Well, that's one way to do it, all right? Let me just think here for a second. This cubed plus 3, this squared times 1 plus 3, this elevated to 1 plus 1 squared plus 1 cubed and divided by 60. Okay, that's one way to do it, but it's not the way the book does it. The book actually wants to expand this stuff, okay? I think the book might be wrong or something, but the book wants to expand this stuff. So it's going to be the integral of what? T to the 4th plus 2t squared, right? Plus 1 dt. All right? And when you integrate this stuff, is going to be 2 to the 5th divided by 5. All right? Plus 2t cubed divided by 3 plus t plus c. Yeah. I think it's the same thing that I did before, except that my answer was in a different format. You would have to get my answer and work things out to put this in this format right here. Now let's see here. The integral of x cubed plus 3 divided by x squared dx. So this is going to be equal to the integral of x cubed divided by x squared. It's x plus 3x squared dx. Okay, dx is everything. So this is going to be equal to x squared divided by 2. Now this x to the minus 2, adding is going to be minus 3 divided by x plus c. Yeah. Now the integral of the cubic root of x times x minus 4 dx. Let's transform this stuff. Okay, so this is x to the 1/3 plus 1. I think it'll be x to the 4/3, right? Because you got 1/3 plus 1. This becomes a 3. Yeah, 4/3. Okay. X to the 4/3 minus 4 x to the 1/3 dx. Yeah, I just multiplied it out. Okay, so this is the integral of all this. So here, you want to integrate this stuff, you have to add a 1. So I think 4/3 plus 1 is going to be 7/3. So it'll be x to the 7/3 divided by 7/3 is going to be 3/7. Okay. Yum, yum, yum. Okay, now let me just think here, guys. Okay, yeah. Minus 4. Now, x to the 1/3 plus 1 is going to be x to the 4/3 divided by 4/3. So it's times 3 divided by 4. Okay? Because 1/3 plus 1, it's 4/3, yeah. So you simplify this stuff in here, and actually in the end you're going to have plus c. So you have 3/7 times x to the 7 divided by 3 minus 3x to the 4/3 plus c. Yeah, that's it. Well, now we're gonna try to understand a bunch of stuff, like some series stuff. What is series? Summation. Okay, it's like summation. For anybody that doesn't know what a summation is, you have, I'm gonna do things like this fast, but it's the sigma, it's the capital sigma. I think this is a sigma or an epsilon. I think it's a sigma. Okay, and then you have an index in here, which can be I or N or whatever, but it's usually I. So you have I here that starts at something. It could be 0, could be 1, could be 2, could be minus 10, but let's just put 0, okay? And it goes all the way to a number here. The number can be infinity, it can be N, it can be 3, okay? And then you have something here that's gonna depend on that summation. For example, I, you can have I squared, I cubed, I divided by 4, okay? So let's just say that it's I just wanna show this to you guys. So it's gonna be 0 plus 1 plus 2 plus 3, okay? If it were I squared, it would be 0 squared plus 1 squared plus 2 squared plus 3 squared. All right. Okay. If it's something like separated like I plus 1, this is going to be equal to, when I is equal to 0, so it's going to be 0 plus 1, 1, plus when this is 2, when this is 1, 1 plus 1, 2, when this is 2, 2 plus 1, 3, when this is 3, okay, because I will go from 0 all the way to 3, 3 plus 1, 4. So that's it. That's what it means. When you have a constant, okay, like I is equal to 0 all the way to n, whatever n is, and you have k, which is a constant I. See, k is going to be everywhere. So when k is equal to 0, this is going to be equal to 0, k times 0, plus k times 1, plus k times 2, plus, and then I'm going to do this 3 dots in here, plus k times n. You see that k is everywhere, so we can factor k out. Okay, we can factor k out, and then you have 0 plus 1, plus 2 plus dot dot dot, okay, which is actually ellipsis, plus n. So now what is this stuff in here? 0 plus 1 plus 2 plus 3, this is the same thing as k times the summation from I equal to 0 all the way to n of I. So you can see that we just look at this function here and look at this function here. Look at that. What I did was just to factor out the k, so when you have a constant, it comes out, okay? And it's out here, right here. All right. And something crazy happens to my computer once in a while, every night. When you have a summation of I, for example, starting from 1 and going all the way to n of what? Of a sub I plus b sub I, for example. This is the same, okay, as the summation of the two things, because I have a sub I plus b sub I. I'm sorry, it looks like a 1, but it's actually a y. This is the same as the summation from I equal to 1 all the way to n of a sub I plus the summation. You can separate the summation. I equal to 1 all the way to n of b sub I. Okay. Now, there are going to be some tried and true summation formulas. I'm not going to prove these things here to you guys. You can prove it yourselves. You know, you can just start summing the things, and you can start the summation adding things. And as you add them, you try to find a pattern, and you're going to see that it just works. So, the integral, okay, from all these things are going to start at I equals 1. I equals 1 all the way to n of a constant. Remember that I said the constant was k. I can also make the constant c, for example. This is going to be equal to c times n. All right? I'm just going to show this one. Let's pretend that n equals 3. Okay? This is so. You have the summation of a c, which is a constant, all right? Actually, c times I, or just c, not c times I, it's just c, okay? So, how many times is this going to happen? It's going to happen n times. So, let's just say that n equals 3, okay? So you're going to have one iteration, the second iteration, and the third iteration, because it goes from 1 to 3. So you're going to have c plus c plus c, which is the same as 3c, okay? So if you have n in here, you're going to have n c's, because you're going to keep going plus c, plus c, plus c, plus c n times. So it's going to be 1, 2, 3 times n times. This whole thing is going to be equal to nc. Okay, or Cn, doesn't matter. In the end, I'm going to show you the formula from the book. Right? If you have a summation of I equal to 1 all the way to n of I, this is going to be equal to I times n plus 1 divided by 2. Actually, it's going to be n. It's n in here. This is a tried and true formula, okay? So what is going to be I? This whole thing here is going to be equal to 1 plus 2 plus 3 plus 4 plus, and it keeps going all the way to n. So when you add all these things, all right, you have this formula here. I'm going to try to prove this to you guys. You have this sequence, right? I'm not going to prove the others, okay? But this one I'll prove because it's simpler. So, make the sequence again, but in an inverted manner. So let's do it. You have n plus. You remember that it was, okay, it's just that what I'm gonna do here, I did all the way to n, but I'm just gonna do all the way to 4. Okay, so you have 1 plus 2 plus 3 plus 4. Okay, add this stuff in an inverted manner, in a reverse order. So 4 plus 3 plus 2 plus 1. Now add these things. You see here that you have 1 plus 4 equals 5. Okay, 2 plus 3 equals 5. 3 plus 2 equals 5. 4 plus 1 equals 5. So adding this stuff in here, then adding the 2 is the same thing, guys, as adding this 1 plus this 1 plus this 1 plus this 1 and then adding them together. You're adding everything, okay? So you can see that it's a 5, 5, 5, 5. So what is the n? N is 4, okay? This is going to be the thing from I equal to 1 all the way to 4, okay? It's equal to this, and it's also equal to the bottom one. The bottom one is just the whole thing inverted. So 1 plus 4 is 5, 2 plus 3 is 5. Can you see that all these are 5? What is 5? 5 is n plus 1, because this 4 right here, in this case, equals n. So you have n plus 1. Okay, how many times do you have this n plus 1? You have 4 times, because n is equal to 4, and you can see that these columns here are going to appear n times, 4 times. So you multiply this by n. But what is happening here? You're adding all these numbers together. You're adding this one, this one, this one, this one, this one. You're adding them all together. But guess what? You're adding the sequence twice. First in the forward order, and then in reverse order at the bottom. But you just want to add the sequence once, not twice. So you divide this thing by 2. Now look at that. N times n plus 1 divided by 2. It's the same thing here. N plus 1 times n divided by 2. That's where the formula comes from. So, yeah, I'm going to show, I know this is really sucky, really confusing, but I'm going to show the summary of all this stuff to you guys later. And now you have I squared. Because remember, first you had C, and then you had I, and now you have I squared. What's going to be the formula of this? The formula of this is going to be n times n plus 1 times 2n plus 1 divided by 6. All right? If you have this I equal to 1 all the way to n, I cubed. These are things that you have to memorize, okay? It's going to be n squared times n plus 1 squared divided by 4. Again, if you have I equal to 1 all the way to n of I equals n times n plus 1 divided by 2. And if you have the summation of I equal to 1 all the way to n of C, this equals Cn. Okay, so these formulas, you just got to memorize them. Okay, so I'm going to show you guys more organized in here. Okay. So I'm gonna erase this thing here because it doesn't matter. And this one in here, I'm gonna try to increase the size like this maybe. Yeah. There you go. All right, take a look at those formulas and memorize them. I'm going to give you guys a second to pause the video, memorize that stuff. And then when you memorize, unpause the video, we're going to keep going. Okay. Now, just an exercise. It's asking to evaluate I is equal to 1 to n of what? I plus 1 divided by n squared. Now, guys, remember that when you have this thing here, this denominator is dividing the whole numerator, okay? And this n is a constant. It's not gonna change as I changes. As I changes from 1 to 2 to 3 to 4, this n squared is fixed, okay? Whatever it is. So if it's 50, it's 50. If it's 70, it's 70. So you can, it's a constant. You can just check, get it out. So I can just get this thing here. I'm gonna erase this. And I'm gonna multiply it over here. 1 divided by n squared. All right. Now remember that the summation of two terms was the addition of the summation of the terms. So this is going to be the same thing as 1 over n squared summation I equal to 1 all the way to n of I plus 1 divided by n squared summation of I equal to 1 all the way to n of 1, which is a constant, remember? Now let's evaluate this. What was this thing? This thing here was 1 divided by n squared, which is the stuff. Now I, remember? I was going to be n plus 1 divided by 2. Okay, plus 1 divided by n squared of the constant. When it's a constant, it's Cn, so it's 1 times n, which is just n. Now, what is going to be this thing here? Well, this is going to be n squared plus n. So let's do this slowly. So we're not going to make any mistakes. So I'm not going to make any mistakes. N squared plus n, and you have a 2 here, okay? Plus n divided by n squared is just 1 divided by n. Okay. So n squared plus n, yeah, n squared plus n, you know, it's dividing this whole thing here. What am I doing about that? Okay. So you have n here, n squared here, and n squared here. You can just simplify this n. So it's going to be 2n, okay? This n squared becomes an n, and this n here becomes a 1. And here you have plus 1 divided by n. But guess what? I want to add these two. So I'm going to put a 2 here and a 2 here. You see, I'm multiplying this by 2 and I'm multiplying this by 2. Let me erase the stuff in here. Otherwise, it's going to look like it's 21. Why do I do that? Because now I have the same denominators. I can just add the numerators. So this is going to be equal to n plus 3 divided by 2n. Is that it? Yes, it is. So you see, this whole thing in here became this. All right? And you know, I think it's too much information for you guys to digest. So I'm going to stop the video and I'm going to continue on the next one.